Morning. Welcome to Sriveda IT. This is DS Prasad, and I'm an AI engineer. So, in the series of recursion, so today we are going to discuss about the fourth concept, that is what is recursive call. So, recursive call or condition. So, recursive call or condition. So here recursive call, which is also nothing but call to the function. So, call to the function, that is recursion function with at least with at least one change. So at least one change in parameter. So parameter, whatever the parameter we are going to take. So that parameter has one change. Once if we change the parameter value, so parameter value, then it satisfies base condition. Satisfies the base condition. So recursive call with at least. So with at least one change in parameter, once if we change the parameter value, then it satisfies the base condition. Or so we can also write like this, the recursive case. So the recursive case is the part where the function calls itself. So the function calls itself with smaller problem. So with the smaller problem. So this is nothing but another example. The recursive case is the point where the function calls itself with the smaller problem. So for example, if I take any example here, so in that example, let's take the function. So function with parameter n I have taken. And so what is the smaller function means function with the change in the parameter means n minus 1. So this is called recursive call. So this is called recursive call. So instead of calling the function directly, just we are changing the parameter and we are taking that function. It's nothing but called as recursive call. And it follows the concept called divide and conquer. So divide and conquer. So how it is going to follow that divide and conquer means it's a kind of like simple, like if there is a big problem is there, and for example, that big problem is function f of 4. Okay. And then, so we need a small problem. So what is the small problem means? Like it has to solve the function 3. So function 3. And again, so it is having another one. So that is called smaller problem. So smaller problem. And it is going to take the function 2. Okay. And again, it is also having a smaller problem. Okay. And that smaller problem is going to carry that function 1. So function 1. And again, it is also having a smaller problem. So that smaller problem is nothing but function 0. So here it reaches that 0, which is nothing but called as a base case. Sir, how can you say that it is a base case? Means, so with the help of experience, so we are going to get that by writing the programs, while analyzing the programs and how we are writing, with that we will understand that how to write the base case and also how to write the recursive call. So then we'll identify that. So which is the base case, which is the recursive call and everything. Okay. And finally, this problem has been solved and we are going to get the output in different ways like 1, 2, 3, 4 or maybe 4, 3, 2, 1. So any case of example that we are going to get. So to get this kind of outputs, let's take an example. So what is that example means? I want to write the numbers. I want to print the numbers from n to 1. So print numbers. So print numbers from n to 1. So this is the first example that we are writing. Okay. So how we are going to write that print numbers from 1 to n means here, for example, n is equals to 5 I have taken. I want to print numbers from 5 to 1 means 5, 4, 3, 2, 1. Okay. And whenever, see that which is the last one, 1 is the last. So here I want to write the base condition. After that one, 0 will come. So whenever if n is equals to 0, then return nothing. Meaning we are going to stop that one. Which one we are going to stop? This recursion case. Here, see that n is equals to 5 here. What is happened to that n? So 1 has been reduced. That is n minus 1. So inside the function, we are going to take two cases, right? One is called as a base case. If n is equals to 0, so stop that recursion. Otherwise, here we are going to take the recursion, right? Inside that recursion, n minus 1, we are going to take that function. It is nothing but a change in the parameters. Let's see that and what kind of output that we are going to expect for this. Let's see that. Okay. Here I'm going to create a function by using the keyword called printf. And after that, I'm going to take that function name as a recursion function name as print numbers. And inside that, I'm taking the number n. And after that, base case, if n is equals to 0, so return. So return nothing. Otherwise, so here I'm going to take that print that number, and after that I'm going to take that. So print numbers recursion function with a change in the parameter has n minus 1. Okay. And after that, so come out of it and n is equals to int of input. Okay. So enter a number. So you can enter any number. Okay. And after that, print inside that print function. So print numbers. So I'm going to take the parameter. So function name and then parameters. If I'm going to call that, output is nothing but 5, 4, 3, 2, 1. And again, I'm getting that none. So why I'm getting that none means because of that, it reaches to that n is equals to 0 and it is returning. So if you don't take this print again, so if you don't take this print and so here, and if I execute 5, now you can see that 5, 4, 3, 2, 1. Okay. So because print of 0 is nothing but right, none. So here I'm using none. So that is the thing. So what if I want to print the numbers from, so here I have taken that. So n to 1, right, which is in the descending order. This is nothing but, so descending order. But I want the print numbers, second example. So print numbers from 1 to n. So 1 to n, which is nothing but n is a greater than 1, which is nothing but ascending order. So which is nothing but ascending order. How to write this program is again same. So if n is equals to 0, then return nothing. So return nothing. The same program, but change in only one line. So what kind of lines that we are going to change? Let's see that. So here, so def, so again, so print numbers. So I want to print the numbers and I'm taking the number as n. So if n is equals to 0, then so return. So otherwise, so uh, print numbers and I'm going to take n minus 1 and after that print. Okay. So print that n value. After that, I'm going to take that. And here again, specify that n value. So int of input. So because input will always take the string format, we are converting that into the integer format. So enter a number of your choice. Okay. And after that, so print numbers, sorry. So print numbers function we are calling and pass that n value. So whenever passes, so now you can see that the output is reversed. So why this is happened? Because print statement here is first and after that recursive case. Here first recursive case and after that print statement. So why we are calling this one as like this? This is nothing but a tail recursion. This is nothing but head recursion. So tail recursion is nothing but in printing the values in the descending order. Head recursion is nothing but printing the values in the ascending order. Sir, how to identify that? What is head recursion? What is tail recursion? What is direct recursion? What is indirect recursion? What is a nested recursion? What is tree recursion? And infinite recursion and finite recursion. Means previously we have seen that this is a infinite recursion. And here this is a finite recursion that we are getting the outputs. Okay. So for that getting output. Sir, how to identify that? So this recursive function before or after the work. This is the work. before work or after the work. So this is work, after the work, and here before the work. How to identify that one? There is a dedicated session for that. So how to write that one? So in that session, we are going to write. So know about everything clearly, and we are going to write any recursion program easily with that concept. Okay. So we have almost 24 plus concepts are there. So we are going to learn each and every concept one by one. Okay. Thank you.